All right, 12.2, surface area of prisms and cylinders. From what I understand, you guys, you should have already done almost everything in this section from previous years, but I'm going to go ahead and dive in. First, let's talk about what a prism is. Remember that we have lateral faces that are rectangles, and these are called the lateral edges, and our bases. All right, and then it says the surface area is the total surface area, the bases and the lateral faces, whereas the lateral area is only the rectangles alone. So only the rectangles. Let me go ahead and mark that up. So just the lateral faces is the lateral area without the bases. So go ahead and draw this figure in your notes with all the different names, just so that we can reference it when we're going through these different cases. All right, a net is just when we take a two-dimensional object and fold it up and turn it into a three-dimensional. So if you can think of it also as taking the three-dimensional object and unfolding it and turning it into a two-dimensional flat surface that would cut up and turn into it. Well, you've seen those before. All right, use the net of a prism. Example 1 says, find the surface area of a rectangular prism with height 2 centimeters, length 5, and width 6. Step number 1 when finding the surface area is, at least when you're getting used to this, is to draw a prism. Now the prism really doesn't have to be to scale, it's just something that you can start off with. So it says the height is 2, whereas the length is 5 and the width is 6. So I'm going to call the height the distance between the two bases, and I'm going to lay it flat on its side. So I'm going to take the rectangle, and to draw this, I draw another rectangle of very similar size, offset, and then I connect the corresponding points to draw my prism. That's all there is to it. And then I mark up the values. So it says that the height, and I'm calling the height the distance between the two bases, 2 centimeters, and I'm saying that this is laying on its side. It's not really a big deal because it's rectangular prism. All of the deals are rectangle. Then we have 5, and I'm just calling the width here 6. It really doesn't matter how you work it out. Just keep it in mind when going through it. Then it says find the area the rectangles form the faces of the prism. Notice that the rectangular prism has faces that come in pairs, like this one and this one are a pair. Then the top and the bottom are a pair. And then we have the side and the other side are a pair. So if they come in a pair, then there's just a pair. Every grouping of the numbers gets multiplied by 2. This is the way that I write it. So I just do 6 times 2, that's one pair. Then I do 5 times 2, that's another pair. And then I have 6 times 5, the last pair. But there's two of every pair, that's why I call it a pair. Well, I lost that, oh well. So I got 2, and then I got 2 here, and we just add this up to find the total surface area. All right, so this is each of the pair of faces, and I add them all up, I get 104. All right, I just want to point out a concept that you may not have seen in middle school, which is going from a right rectangular prism, something you're probably familiar with, to an oblique rectangular prism. We have a height here, and the height is perpendicular to the base. Even though this is what we could consider a slant height, it's the hypotenuse of a right triangle that corresponds with it. Go ahead and draw both of these drawings in your notes and write the labels, talk about the difference between the two of them. All right, this is a formula for the surface area of a right prism. Yeah, the formula's here. You're welcome to use it, but really I think it's better if we just think of it a little bit differently. I think it's better if you think of it as two bases, which in this case are triangles. You take 2 of the bases, and you add it up to all of the lateral faces. When you approach it from the standpoint, there's really no need to remember the perimeter and the height and then add it to the 2 bases. Just think of it as the area of the 2 bases plus the area of all of the lateral faces combined. You're welcome to use the formula. I'm just not going to because I think it's more obnoxious than necessary. Here's what I mean by that. If we're to find the total surface area, by the way, if it doesn't say total, it's assumed to be total. Only when they put the word lateral in do we find the lateral only. Notice this is just 2 times the base plus each of the rectangles. This is a regular pentagonal prism. That means that all of these rectangles are congruent. So let's find the area of all 5 rectangles. In fact, I'll do 5 times the area of the rectangle plus 2 times the area of the pentagon. Notice this is something like we did last 6 weeks. Each rectangle, if the side length is 7.05, is 7.05 times the height, which is 9. There's 5 of them. Plus 2 times the area of a pentagon. I need to do a little work to get this. So I'm going to come over here and say that the area of a pentagon is 1/2 times the apothem times the perimeter. Remember, the apothem is this perpendicular distance. I'm going to draw just this triangle, and so I can identify the apothem, and the perimeter is just 5 times 7.05. So let's go ahead and find the perimeter first, and then I'm going to find the apothem. So the perimeter is 5 times 7.05, which I get to be 35.25. I'm going to tuck that away for a second, and then I'm going to worry about finding this apothem right here using that triangle. Notice the radius is 6, this is 7.05. So when I drop the apothem down, the apothem is referenced to this triangle here, where 7.05 divided by 2 is the leg, one of the legs of that right triangle, and using the Pythagorean theorem we can solve for A. I'm going to do that work down here. Whoops. I get A is approximately 4.86, but I'm going to leave this stored in my calculator. In fact, I'm going to press stow alpha A so that I can recall this up here. So I've got this stored in my calculator, and then I'm going to write 1/2 A times the perimeter, which I have the value of 35.25. Now that I've got this all here, and I have stowed in my A, or stored in my A, I can just type this in one swift move, which I'll do right now. Which I got the area, the total area to be 488.4. And this is feet squared, surface area of our pentagonal prism. All right, go ahead and pause the video, try to do these two problems, and see if you get the same thing as me. All right, here's the net for a triangular prism. Triangles are bases, 3 rectangles going between them. I think it's really obnoxious and tedious to draw a net for a right rectangular prism to find the surface area. I think it's better just to do 2 pairs, a pair of 7 and 3 base, 3 and 4 face, and a 7 4 face. I just multiply by 2 every time, add them all up, I get 122 inches squared. All right, the next concept has to do with cylinders. Notice we have a cylinder. Go ahead and draw the cylinder in your notes. We have a circular base, another circular base, and a height between the two of them, just like a can. Go ahead and draw that figure in your notes. Also draw all that you see here, because this is necessary for understanding the different pieces of a cylinder. Notice if we take the cylinder and unravel it, just like a Coke can, we're going to end up with a rectangle in the middle. The hardest part when solving problems dealing with the net of a cylinder is that this length right here is the circumference of a circle. Has to be, because this length right here, let me change colors, this length must completely wrap around this circle, and this one down here. So this still is 2 pi r. With that information, we can use it to create the formula for the total surface area of a cylinder. Notice that surface area is 2 times the area of the base, capital B stands for the area of the base, plus the area of the rectangle. Well, the rectangle is the height times the circumference of that circle. So it's just 2 pi r h. Remember that the area of the base is just pi r squared. So our formula is 2 times pi r squared plus 2 pi r h. There are different forms of this exact same formula, but that's really all it boils down to. To be honest with you, I don't have this formula memorized as outright like it is. All I do is just think of it as a picture, and then I reason it out. But if you need to, go ahead and write this out right here with this picture to help you remember how to find the total surface area of a cylinder. I'm going to skip this example and get into some that just deal with the numbers. Find the height of a cylinder. So notice we have the area, total surface area, is equal to 2 pi r squared plus 2 pi rh. By the way, this is on the formula chart. You don't have to memorize it anyways. We're solving for the height. The height is the unknown, but the radius we do know. This is 2.5. We still have the 2 and the pi, and the 2.5 squared over here times 2 pi. And then our area is 157.08. All we need to do is solve for that h right here by undoing everything else that's next to it. So it's just 157.08 minus 2 times pi r squared. And then you're going to take that, you're going to end up dividing by 2 pi times 2.5. you might want to pause the video and think about what I just did. I did all the algebra in one step. If you need to, go ahead and do multiple steps and see if you get the same thing as me. And then it just comes down to a simple plug and chug, since all of this is just numbers. And I get the height to be approximately 15.71. And this is meters. Okay, that's it for the video.